Hey everybody, Kyle here, Tech and a Trainer for McNeil. I got a case through Tech this week that I thought was kind of interesting, and it's this very cool model of an airplane, but the specific area that the user was having trouble with was this area right here. And what they were trying to do was to actually make this a little bit deeper. And you can see that if I drag this in and let it go, it's going to think about it for a second, and it will actually do it, right? But you notice the performance on this is pretty slow. What they were trying to do actually was extrude this, and you'll see that Rhino chokes, and they were worried that this might be a problem with V8 or whatever. The same problem happens in V7. And this actually ends up being something that we actually have to end up killing Rhino over, because this actually just freezes everything up. And I wanted to talk a little bit about how I diagnose this and try and figure out what's going on. And it turns out that what it comes down to is the original curves that make up this extrusion make up surfaces that end up having a problem. And I wanted to talk a little bit about how to deal with that and some strategy for how to handle that. So I'm going to just kill this because it's going to die. So we'll get the model back open and we'll take a look at what's going on here. And the surfaces that we want to work on are essentially all of these. So I'm going to pull all of these out with this part, and I'm going to isolate them. And we're going to talk a little bit about what's going on here. So if I start disassembling this, which is usually what I do when I'm dealing with a client file, is I look at a few things. And the key thing that we're going to talk about here is the difference between overbuilding a surface with a simple curve, ending up with a simple surface, or building off of a trim edge. Now, I'm not going to sit here and tell you that you can never build off a trim edge, because that's not true. But what needs to happen is the trim curves themselves actually need to be really high quality. I can just see visually that we've got an issue right here. You can see that there's a kink in this corner, which is not supposed to be there, which tells me that there may actually be a problem with the trim curve itself. So I'm going to go to the standard tab. I'm going to untrim this, and I'm going to keep the trim objects because I want to see what the actual curves look like. And in this case, I may just go ahead and untrim all of this completely. And let's take a look at this curve. Now, this curve has a lot of information in it, and probably more than we need. And if I were to simply extrude a surface off of this, you can see that the point structure, first of all, it's a poly surface. Second of all, the point structure on all of this stuff is kind of way more than we need, right? This is like a lot. And so I think there's a way that we can improve this entire situation quite a bit by, first of all, talking about this surface itself. And if I look at the point structure on that, I can see that not only is this a very, very simple surface, but if I change degree on it, you'll see that it's actually a degree 1 in that direction. So I'm going to change it to degree 3, and it's a degree 2 in the other direction. So I'm going to change it to that. So now we've got a single span. If I go to wireframe, we've got a single span surface with 4 points and 4 points in either direction. So this is a nice high quality surface. It's nice and even. It's good to go, like all that kind of stuff. So if I were to simply just trim another hole out of this and make another surface, I wouldn't have gained anything. This wouldn't have bought me anything other than maybe this little ribbon here would be in a little better shape than it started. But what I'm going to do actually is I'm going to flatten this curve to 0. Right? I'm going to just scale that with gumball. And you'll notice that if I were to extrude this, it's still going to do that thing that we don't want it to do. So let's take this and isolate that part and take a look at this curve in the other view and see if we can clean this thing up a little bit. And so what I'm going to do is I'm going to make a new layer, and I'm going to call this the OG curve, and we're going to make this red so that we can see it. And I'm going to apply this. I'm going to copy an object to that layer, and then I'm going to work on this particular one. And I might actually hide that for the time being so that I'm just working on this one. I'm going to explode this curve and take a look at its components. And in this case, you can see that the components itself are actually, this is pretty okay, right? I mean, it's a straight line or a straight-ish line, so that's probably fine. That one's probably fine. That one's probably fine. This one's probably fine. The problem comes not only in the complexity of the corner in here, but look at the tangency sitch right here. If I were to put a curve comb on this, you could see that we end up with a massive disparity in the fact that there is no continuity between these at all. So what I want to do is I want to run the match command, and I'm going to match this from here to here, and we're going to do that tangent. And you can see that it does just a little bit of a change. I'm not going to average and I'm not going to join it, but it doesn't take the bump out. You can actually see that this point is below the curve, which means this curve actually is inflecting. If the points are below and above, the curve is inflecting there, which means that has a bump in it, okay? So let's fix that. Let's go and grab a blend curve, and let's blend from here to here, and let's draw a better version of that curve without the bump in it. And you can see where the bump is right here, right? This is a tangency issue, and if I can come up a little bit, and maybe I'm going to fuss this a little bit, and it looks like the curve kind of is telling us what it wants to do. So I'm going to just delete this guy, get rid of that. Now notice the quality of that curve versus what we had, okay? And I can look at this and I can say that and that are going to join up fine. So let's do the same thing here. Let's do a blend down here. And we're going to go here and here. And I don't want to throw this user under the bus. I don't want them to feel like they did anything wrong. What they probably did was projected a curve onto a surface. And when you project a curve onto a surface, you get that extra complexity built in to the curve. And we'll talk a little bit about that going forward. But let's go ahead and just clean this up again just with the blend tool or blend curve. And he probably used a blend curve to start with and ended up getting the result that he got after he projected it. So now we're going to clean this one up. And it's not an exact match because we did have a tangency problem with the original curve. So now we've got this, and I'm going to join it. And look what happens if I extrude this. We have a much simpler version of what we had before. It's still a poly surface because it's polycurve, unless we were to rebuild this into one single curve, which then we would have issues with the shape and all that kind of stuff. So nothing wrong with a polycurve. Let's bring the part back. And if I take this now, and let's take this surface and this object, and instead of projecting this curve, let's just do that. I'll show you what it looks like. Let's project this curve onto that surface. What happens? Looks great, right? Except if I turn the points on for this, look what happens. We're right back to where we were before. Okay, compare these. Look at how much more complexity there is in these corners. That's not what we want. So what we're going to do is we're going to not do that. We're going to take this and we're going to extrude this through this object. We're going to overbuild it. Okay, this is what we're referring to as overbuilding. And then we're going to trim this object. And I want to make sure I'm trimming the right part. So I'm going to take this object and trim this. And that looks okay. And then I'm going to take this, and I'm going to trim off that, and then I'm going to take this inside, and I'm going to trim off that. And you can see that we have essentially the same thing that we had before. And if we get, I'm going to get rid of this little ring right here of the old stuff. So now we've got the new thing stuck in here. Now, if I take this thing and I join it all back up, if the world is a kind and a just place, this should update much quicker. And it does. And you'll see that the performance on that is much better. And if I take this and I extrude it, it will now do its thing, right? Because we got rid of whatever it was in that curve. And I don't know what it was, but there was something in that curve that was causing this extrusion to fail. And so the performance on this was really, really awful. And so this idea of overbuilding something versus building off of a trim edge can be super useful, especially in cases like this. And in fact, I would probably go even further, and let's go back to here. And let's get rid of, hide the other stuff. I would probably even go further and get rid of all the original stuff. And if there's no problem with the outside, you know, don't fix what's not broken. But in this case, there was this stuff on the outside was fine. There wasn't anything to do in here. I would, to be fair, probably do this same exercise with the external shape here. I would probably take this curve, the outside curve of this, flatten it, rebuild it, make it all nice and clean, and then I would probably extrude this entire thing as one piece. That's probably how I would end up doing it. But in this particular case, we're going to call this fine, and it you know, it joins up fine. It's clean. It doesn't have any problem. What I would probably do, and the way that I would probably model this, is I would just take this and I would just extrude it straight through as a closed object, and then you can either trim it or Boolean it. In this case, as long as the normals are facing out in the right direction, this should actually Boolean just fine. And that gives us this result. Now, the cool thing about this is this stuff stays nice and light. Whereas if we were to, you know, have extruded that off of the trim edge, you know, that's where the problems come. So anytime you can overbuild to get simple objects, these objects keep their simplicity now, right? Now the trim edge, let's duplicate this trim edge for a second, and I'll show you the trim edge still is complex, right? And that's just, there's no way to avoid that. That's just how projecting curves onto a surface, they end up being an edit point curve on the surface, and they end up being complex. That's all there is to it, okay? The way to avoid that is to not build off of the trim edge. Just overbuild it and then trim back. Now, this will still fill it nicely and all that kind of stuff, and it does join up nicely, but you can see that the performance on this is going to be much better now that we have fixed the underlying problem. Okay? Bring that back, join it up. The model's closed. It was a very high quality model to start with. It just had this one little geometric problem in it. And that would be how you would fix it. Okay? Hope that's useful. Go make great stuff. Thanks. Bye.